Hello my dear students of BSc 6 Master. So welcome to physics classes by Sidhu. So today we are going to discuss topic that is Langevin classical theory of paramagnetism. In the last lecture we have studied Langevin theory of diamagnetism. Clear? So what is the difference between them? In a diamagnetic case the susceptibility have negative value, but in the case of paramagnetic materials the susceptibility have positive value but very small value. Clear? In that case, a mu r relative permeability that is less than 1. But in this case, susceptibility have positive value, so mu r is greater than 1 in this case. Clear? Second, what are paramagnetic materials? What are paramagnetic material? Paramagnetism in these materials arises due to please pay attention, due to the presence of permanent magnetic movement in constituent atoms or molecules. Okay? So the paramagnetism in the materials arises due to permanent magnetic movement of the constituent atoms, and this permanent magnetic movement is the combination of two movements, that is the orbital motion of the electron and spin motion of the electron. Clear? And in the absence of magnetic field, these dipoles randomly oriented. These dipoles are randomly oriented themselves, and when we apply a magnetic field, they orient themselves in the direction of magnetic field. So when they orient themselves in the direction of magnetic field, then there is a net magnetization. Means there is a net dipole moment. If there is a net dipole moment, then there is a magnetization, because we know that magnetization is net dipole moment per unit volume. If there is a net magnetization, then there is a susceptibility. The susceptibility, so in this case, have positive value. Very small value but positive value. Clear? So this is all about introduction of paramagnetism. So in the materials arises due to permanent magnetic movement of the constituent atoms. So the magnetic moment orient randomly and net magnetic moment becomes 0 or very less. But when a magnetic field is applied, these moments orient themselves along the field direction and there is net magnetization. Susceptibility have positive value but small. Clear? Then we have to discuss Langevin theory. So these are what Langevin said. He considered a paramagnetic gas. In which each atom or molecule possesses a permanent magnetic moment. I have written for all of you that so notes, you have notes of this you can say topic. Okay, I can provide. So he considered paramagnetic gas in which atoms or molecules have permanent dipole moment first, and that magnetic moment when gas is subjected to magnetic field. Clear? Magnetization is, now gas is gas or paramagnetic substance that is subjected to B. We apply magnetic field. When we apply magnetic field, then there is a magnetization, and that magnetization is determined by two factors. These are very important. By two factors. What are these two factors? First is the applied magnetic field, which tends to align the magnetic axis of the dipole in its own direction. So this is a paramagnetic substance. So this is P, and B you can say also. Clear? So it exists as a dipole. Equal and opposite force lag rahi hai, then that there is a production of torque. Torque that is equal to the force into perpendicular distance between these two. Clear? And the net dipole moment that is equal to mu. Net dipole moment, you can say the moment that is dipole moment is in this direction, mu. Now this dipole makes, atom is like a dipole, magnetic dipole. This dipole makes an angle theta with B. With B. B is the applied magnetic field. So this is a magnetic dipole, paramagnetic substance. In paramagnetic substance there are so many number of atoms or molecules. So I consider this dipole and equal and opposite force at the ends of these dipoles. This force, and there will be a perpendicular distance between them. So multiply this force with perpendicular distance, you can find out the torque. Okay? So that we have done in +2. From that we have found potential energy. Clear? So that I will write directly here. So this is about first factor. Clear? Secondly, we apply magnetic field. The dipoles orient themselves in the direction of magnetic field. Now, when temperature is raised, what will happen? There must be a thermal agitation by the atoms. There will be a thermal agitation. So due to that thermal agitation tends to disorganize the orderly state so produced. So orderly state that disturbs means magnetization that decreases, dipole moment decreases. So in this case we have to apply a proper temperature and stronger magnetic field. Then there will be a net dipole moment. Clear? We have to apply a proper temperature, particular temperature. So thermal agitation will be less, and secondly the field must be stronger. Field must be stronger. Then after that we have calculated magnetic potential energy. Clear? That we have I will not told you how we can find out this potential energy, because we will not discuss this, because that we have done in +2. Clear? If you want, you can give me a comment in the comment box. I will give you the detail. So that will be mu b cos theta, because this is applied in this direction, b is applied. So this is negative. Clear? Mu m, this is mu m. Clear? Now what will be, this is energy E. Now E potential energy, that is equal to minus mu m b cos theta. Yes, from this if we differentiate this with respect to theta, then dE is equal to minus mu m b sin theta cos theta, derivative of cos theta, that will be sin theta, derivative of cos theta, that will be minus sin theta. So minus become plus, so into d theta. So dE is equal to mu m b sin theta d theta. So this is the value of dE. Here? Here see? Now if there are according to Maxwell MB statistics, the Langevin Curie uses MB statistics. So according to MB statistics that we have also done in second year, according to this, the number of molecules or atoms between energy, number of atoms per unit volume, you can say, per unit volume, between energy E and E plus dE, between energy E and E plus dE is proportional to, so dN, that we consider dN, the number of molecules between energy E and E plus dE, dN, per unit volume, dN, that will be proportional to, that is proportional to e raised to power minus E over kT into dE, between E and E plus dE. Okay? So constant of proportionality we use here A. Clear? So this is equation number first, this is equation number second. Now put the value of dE from equation number first in equation number second. So dN, that is equal to A e raised to power minus E over kT dE, that is equal to mu b sin theta d theta. Clear? So this is dn. Now we know these are the number of particles, number of molecules per unit volume between energy E and E plus T. Now total number of atoms, if we want to find out, then number of molecules, then we have to integrate this. So number of molecules, total number of molecules between inclination theta, that is between 0 to pi. So n is equal to integrate, a is constant, we take it outside, 0 to pi integrate mu m b e raised to power minus e upon kt sin theta d theta. So this is n. From this n we can find out the value of a. So take equation number 3rd. So from this the value of a will be, I rub this, can I rub this? So from this a is equal to n upon 0 to pi mu m b e raised to power minus e over kt sin theta d theta. Take equation number 4. This 4. So we have these type of equations. So we have dn, these types of equations in the last dn. Okay. Now a is equal to this. Now all the dipoles orient themselves, when we apply a field, they orient themselves in the direction of magnetic field. So if each dipole have a magnetic moment, that is equal to mu m b cos theta, because they align themselves in the direction of magnetic field. So net magnetization is total dipole moment per unit volume. So if we multiply this by total number of atoms per unit volume, then we will get the total magnetization. So total magnetization m between the total magnetization, that is equal to, for one dipole mu m cos theta, sorry, this is potential energy, mu m cos theta is dipole moment. So each dipole have magnetic moment mu m cos theta in the direction of field, because field dipole is in this direction, field is in this direction. When it orient themselves through torque, orient themselves in the direction of magnetic field, dipole moment of each dipole is mu m cos theta. If number of dipoles multiplied by number of dipoles, number of molecules per unit volume, then we will get the magnetization, because magnetization is number of dipoles per unit volume. So m is equal to mu m cos theta into dn. So full join, forget this, mu m cos theta into dn. And what is dn? dn is the number of molecules per unit volume between the energy E and E plus T. And when we integrate this between the limits 0 to pi, because we are considering the dipoles having orientation between 0 angle between 0 to pi. So when we multiply the dipole of moment of each dipole with the dn and then integrate it, we will get total magnetization. So total magnetization, that is equal to integration of between 0 to pi mu m cos theta dn. Now put the value of dn from this, okay, that we have done in the previous. dn is equal to this. So put value of dn, a is for minus e over kt mu m b sin theta d theta. Now then put the value of a from this equation. So this is mu m cos theta e raised to power minus e over kt mu m b sin theta into d theta. Here a, value of a is n by this thing, n is here, over 0 to pi mu m b e raised to power minus e over kt sin theta d theta. Now value of e, the value of e we have write at the start, we have e is equal to minus mu m b cos theta. So we have written in the previous So put the value of E. E here. E is equal to minus mu m b. So when you put the value of E here, minus mu m b cos theta, this will become positive. So mu m b cos theta over kt. Same here, mu m b in denominator cos theta upon kt. Clear? Now we have net magnetization of this type. Now m is equal to, taking mu m, 1 mu m this side, because this is also constant, this b is also constant, mu m b, this mu m, here is also b, mu m b sin theta, okay, e raised to power this. So this mu m b and this mu m b, they cancel with each other. So this mu m, because they are outside, they will be outside the bracket. So this mu m outside the integration, sorry. So n into mu m, integration, Now integration is this. Now here we will put mu m b, pull jo beta isnu, forget this. Only you cancel mu m b. Clear? Cancel. Then put mu m. मैं शॉर्ट किया, ठीक है, mu m b upon kt नु x put कर दो. Put mu m b upon kt, that is equal to x. So put it x. Clear? So inu x put कर दो and cos theta, put cos theta is equal to y. Put cos theta is equal to y. Yes, mu m b upon kt नु तो upon की put करता है, x put करता, we have put this. So this is, and cos theta y put करता. Cos theta का derivative minus sin theta d theta, that is equal to dy. So same here, this is sin theta d theta, this will be dy, this will be dy. So minus will be outside, same out here, sin theta d theta, sin theta d theta, this sin theta d theta, this is equal to minus dy. So this is dy, this is dy. Clear? Then this cos theta, that is equal to y. This is equal to y. Clear? This goes this y. Then n into mu m, outside, this goes outside, and this cancelled. This when we take it outside the brackets, this and this goes. Then what is remaining? E raised to power mu m b cos theta. Mu m b upon kt, that is x, e raised to power x. Cos theta, that is y. So we have this. Clear? We have this. Clear to all? Then integrate it by parts as shown in the shortcut. So by parts after solving this, because limits become when theta is 0, y is plus 1, when theta is pi, y is minus 1. Okay? When you solve the integration, you will get this thing. Okay? Then what about this? This will, this is cot hyperbolic x. Cot hyperbolic x. So put this as n mu m cot hyperbolic x minus 1 over x. You have this, m is equal to this. Now, case first, when m, we put x is equal to case first, when x is equal to mu m b upon kt, that is large, this is large. When x is large, when t is small, when t is small. So at that time t is small. So when t is small, x is large, what will happen? Then this cot hyperbolic x and minus 1 over x, this is equal to Lx, and this is called Langevin function. Clear? Then at that time, clear, this become Langevin function. So at that time, m is equal to n mu m into Lx. So this is m 1, then M is equal to N mu M and is called MS, saturation, magnetization at saturation. Clear? So when we plot a graph between M over MS is magnetization at saturation point when Langevin function is 1. With X, you will get a graph like this, and this is the highest value, and that is M mu M over MS. M over MS. Clear? So second case, when X is small, temperature is high, then cot hyperbolic X, that is equal to 1 plus X by 3 when X is very small. So you can directly put it. Okay? So when cot hyperbolic X is this, then what about Langevin function, that is equal to 1 over X plus X by 3 minus 1 over X. So minus 1 over X goes with 1 over X. This is approximate equal to X by 3. And we have M. We have done M is equal to this. So M is equal to N mu M into Lx. So put the value of Lx, that is equal to M into mu M into X by 3. Now put the value of X also. So that is equal to N mu M B upon KT. And that is equal to N into mu M square B upon KT. Put B is equal to mu H. Put B is equal to, here B is equal to mu H. So mu M square mu naught H upon KT. This is M. And we have susceptibility, that is M by H. Clear? When you put M by H, H goes with H. This is M. So when we divide it by H, H goes with H. What is susceptibility? N mu M square mu naught upon 3 KT, because you have to put Lx is equal to X by 3. N mu M B upon KT, this 3. Clear? This 3 upon 3 KT. So or you can say this is equal to C by T, where C is equal to N mu M square mu naught upon 3K. This C, only T, this is C. This is C. Curie constant. And susceptibility is, from this you can say that susceptibility is inversely proportional to temperature. This is Curie law. This is Curie law for paramagnetism, and this is the value of susceptibility for paramagnetic material, magnetic susceptibility. So it is inversely proportional to temperature, where C is the constant called as the Curie constant. Okay? So from this you can say that the magnetic susceptibility for paramagnetic material have positive value, and if susceptibility is positive but small value, then what about mu r? Mu r is equal to 1 plus susceptibility, that is greater than 1. But in the case of diamagnetic material, this was less than 1. So this is all about the, and when you have to plot a graph between xi and t, the graph is like